Okay. Okay. Can I tell you what the secret is? Why the initial age of obesity was so low? So I figured it out, and it is with some regret that I figured it out. But it highlights a bug that we need to fix, and it's an easy bug to fix. But it's a bug that requires both a didactic one, in this case, didactic distress. Okay, so the answer is, why is it that, so the question was raised, and I'm just so grateful for it, that the initial age of obesity histogram seemed really far off, and in the sense that most people were getting it between age 0 and 20. And I said, well, and then it had this mean age of diabetes, so it's like 5, of becoming obese, 5. And I said, what the heck is going on here? So then I went and I started futzing around with these rates, and I couldn't find anything weird with those. And so I said, well, maybe it's something to do with, maybe it's computing the mean from the BIMD data. So I actually went up here in Maine, and I went and I checked the BIM data, and I said, what to be 100 intervals, not 10, and each one is size 1, so age 1, 2, 3, etc. And I did that, and I'll show you what I saw, and we will help, you may follow along my path to realization of what we need to change. Okay, so here's our mean age of obesity. Now mind you, we're still only 3 years in, we're going to 5 years in. Look at all this. Look at all this. What's the mean age of obesity? Look. It's like, it's not only 0. Look at that. Look at this. It's between -1 and between -1 and 1. They're obese in the room. But then I realized, if only I had used my full name. If only I'd used the original name. Ladies and gentlemen, do you remember it? Not 2 days ago, in this very room. Actually, I'm not sure the original name would have saved us, but it might have caused us to reflect on this. Age of first obesity episode. Do you remember my original name for that? Do you remember? Yes, it was many times longer, but it said age of first obesity episode or -1 if not yet obese or something like that. The fox has shown its tail. Okay, so the answer is, this thing is initially -1. So if someone is not yet obese, it treats it as -1. So they are being counted as if they were obese at -1, and they are skewing the statistics something horrible. So, how are we going to fix it? Well, fortunately, it's not very hard. Fortunately, it is something to which we can now attend, even with the heavy responsibilities upon us for the balance of the morning. Even before the crown jewel, we must polish those jewels which adorn us now. Okay, so I just went to record initial obesity age histogram. Okay, I just realized this is off. Perhaps that's why I'm shouting too much. Okay, so, ladies and gentlemen, I just went to Maine, record initial obesity age histogram. I submit this code to you, and I consult with you. What do I need to do? What do I need to do? It's actually a one-line fix. Well, if you don't count the curves. One-line fix for this. What do I need to do? I need to, from those statistics, I need to exclude who? Get rid of those folks with the -1. Those are red herrings. So, this is what you do. I know you don't like those, but So what you could, well, you could change it to 0, but it would still skew the statistics because it would say the mean is, count all these ones as 0. And whatever you change it, so what you need to do is this, ladies and gentlemen. You need to say if person dot age at first obesity episode equals minus, well, if it's less than 0, if it equals -1, less than 0 is more robust. Equals -1 will be fine. So I'm going to do this for clarity. It's only under those, if it's not equal. Guess how you say not. That's how you say not. That is it. Pound. Where am I? I am record initial obesity age histogram in Maine. I just changed it, ladies and gentlemen, from merely this to, oh gosh, now I destroyed it. Okay, I'll put it back in. I changed it from that to this. Okay, I saved it fortuitously. Okay, there. This is what I did. That will fix the problem. That will exclude from our analysis all those people for whom they have an initial obesity episode at age -1. In other words, those who haven't yet become obese. Does that make sense? So they were screwing over that whole calculation. Those people were, there might be one who required it at 10, and then there were 9 of them who required it at, quote, -1. And so it skewed the statistics, the mean statistics. Remember that autocomplete is your friend, control space. No, there's no comma. Nope. Commas are used to separate, when a function needs some information to do its job, it needs to separate little pieces of information that you have to get to it. But in this case, there's nothing like that after the F, so you just put it there. It's throwing errors? Okay. Okay, who needs help? The TAs are willing to help here. Who needs help? Who would like help? You should be able to, after you do that, you should be able to build. Did you build? Did you build? Ladies and gentlemen, build or not? Build. Okay? Let's run it. Let's run it. Are we ready to run? Are you ready to run? Okay. Okay, now wait a minute. Okay, ladies and gentlemen, my fix, okay, okay, don't tell me. Mumble. Okay, I think okay. Mumble. Okay. Sorry. Let me just try this because that should have worked. But Dylan, do you see a logical problem with what I did? So let me put it back in there. And I don't. I didn't fix the actual code. I just did it in the text editor. Sorry, I did it on the big screen, but not on the small screen. So if it's not equal to -1.0, then do this. Sorry, all I did it was here, and then I ran the original code. Okay? So this is what's on. Okay. So let me change that back. This was not equal to -1. There's no reason to doubt the accuracy of that. Hey, come on. Not equal. I don't know what's going on. Something funky is. Oh gosh. Sorry, my machine is exhibiting transient dysfunction. So so I did fix it, okay, now we're running it, and now we're hunky-dory. Do you see that? Okay? Are you okay? Okay. So now it's saying, okay, mean age of obesity is 44.45, something like that. I have 43. And this is the age of obesity, right? That was an emergent property of the model. We didn't put that in. It results from interactions of mortality rates, interactions of people gaining overweight, losing overweight. It reflects characteristics of the population's initial demographics. And as we run it, this will become, more, a little bit larger, but it's fairly stable in its depiction. So we have some childhood obesity, but most is acquired in the 30s and 40s and so on. Okay? Okay, ladies and gentlemen, are we ready to move forward for the crown jewel? For the ICID garment? Okay. You steeled yourself? Okay. So I'm running it out. And having run this out, I would like to write down, I would ask you to write down some numbers, okay? I would ask you to write down, once it gets to 50 here, I'd ask you to write down these numbers from the qualities and from the costs, okay? So they're rising, and we're going to record those numbers for at the final time, and then we're going to run an intervention scenario. Okay? Okay. Just the qualities, the undiscounted qualities and the undiscounted accumulated costs. Okay? Just so we can write down two, I've chosen the undiscounted ones. And by the way, you know what you can do? It's a thing of beauty. You can right-click on this and say copy. So when I say write, I do so in a loose definition of it. So here we go for the accumulated costs. This is baseline, right? Baseline accumulated costs, and now baseline accumulated qualities will be this one here. So I right-clicked on that and I paste that in. So qualities will be this, and costs will be that. All right? And there we go. That's baseline. Are you okay with that? So what I did is I right-clicked here and I did copy, and then it's different numbers from you. Slightly different? I have 1,000 people. What are your numbers?
Yeah, the 2 million in costs.
Okay, write down whatever numbers you have. I mean, there may be some difference. So I think there's probably some divergence of our models somewhere along the way, but we don't have time to go figure everything out. So as long as your model is consistent, we will compare that model for the baseline and for the intervention. So our focus today will be on comparing the baseline to the intervention. How many have numbers similar to mine? I'm doing the undiscounted. The undiscounted ones are these guys here. The discounted ones are the ones below. We're doing baseline. Running the baseline. Let's go.
So I'll note that it is really easy to run just simulation rather than baseline. So you can show them explicitly how to run the baseline and make sure that we are running baseline. That will probably make it more
So I try to always, in this boot camp, I try to always encourage you to run a simulation, run an experiment, run a scenario by right-clicking on that itself and choosing it, and that helps avoid a lot of risk of accidentally following into running the last one where you meant to run another. So as Dylan said, if you right-click on baseline and run it, you will then be very explicitly running that scenario. Okay? Okay? So do people need a bit more time for that to complete? Okay.
Maybe some areas that do something about your brand.
Could be. I wouldn't expect it would yield that much variability because it's kind of the difference. I'm on fixed seed here, but I wouldn't expect it would lead to really pronounced variability. A little bit, yes, due to stochastics. Okay? So, ladies and gentlemen, are you ready to go on? Did yours finish? Who needs a bit more, your cost of? Okay, so as long as you're consistent, let's just go with that. Okay, ladies and gentlemen. Hello? Ladies and gentlemen, we will now proceed. Okay. So, now I'd ask you to run the scenario that involves a lower rate of acquiring overweight, reducing overweight incidence intervention. Run that. And here we go. I'm running it now. How did I run it? I right-clicked on it and clicked run, which I think is the technique all of you have been using, but I may be wrong on that. Overweight incidence. Reducing overweight incidence. Okay, ladies and gentlemen. So mine is accumulating here. We're 30 years in. Are you folks running that? Okay. I'm running this in a virtual machine, which means it runs slower than some of yours. For some of yours, you may have finished it. If so, I'd like you to write those down, those numbers down, making it clear which numbers are from the baseline versus which numbers are from this alternative. I'd like you to write down those two same corresponding numbers. Okay? Mine approaches is finish here. Okay, so here we have now just about at the end of this simulation. Okay? Okay, so I have accumulated costs and qualities. Okay, that's interesting. My qualities are higher and my accumulated costs are lower for mine. So this is reducing overweight incidence, right? And here my accumulated costs are 11 million. And my costs or my qualities are 96,000, as compared to my, in the original case in which there were 90, what am I doing? Put a dollar sign, one of them, most egregious. Okay, so these are qualities here. So this is an alternative scenario, right? Thirdly, I would like you to now evaluate the scenario reducing obesity incidence. Reducing obesity incidence, we go to that scenario, we right-click on it, and we click Run. And I'd like you to run it and evaluate the outcome of the intervention here in terms of those same measures. Help you?
Very smart.
Okay. So be sure to label each of those accordingly. Oops, this is reducing obesity incidence, this latest one. Now you could be pasting these into Excel in nice columns. That would be a more favorable way to do it. Okay? Yeah. Okay. Okay, so ladies and gentlemen, we are going to now, having compared those, we're going to, what I'd like to do is actually to put these into Excel, if you have that ready, and you can perform some calculations there. What I have for reducing obesity incidence is, so the accumulated costs are 12 million, and the qualities that have been accumulated are, the qualities are, okay, yes, the qualities, okay, that's very interesting. Did I copy the right qualities? Okay. So look at that. That's quite interesting. Sorry?
I had that for the other one, reducing overweight, I had this massive gain in qualities, not so much for this one.
Yeah, that's very, very interesting. Okay. And then finally, let's do this for the case of losing overweight. Now, I would like to suggest that you put these into Excel so you can easily do calculation. So I'm going to go to Excel here, and we're going to have two columns. One column will be associated with qualities, or one column with costs. And so we're going to have costs here, and we're going to have qualities. And then we're going to have interventions on successive rows. Okay? So this is going to be baseline, and then I'm going to copy from each of my notes here, reducing overweight incidence. This is all occurring while my latest one is running. Okay. There we go. Obesity obesity incidence, and then I'm going to be doing, so enhancing, losing overweight, right? Elevated, okay, that's weird. Elevated overweight loss, overweight shedding, okay? And then on the cost side and on the quality side, I will copy in this data. Now, unfortunately, the default isn't large enough to expand it, so I will look here. There we go. And qualities, I will copy in similarly. And I will do this for each of mine. Meanwhile, these things are running my latest one. Okay. Okay. Hey, get back there. Okay. There we go. Okay. Hey. Okay, I need to go back to this. Okay. Hey. There we go. Reducing obesity incidence is this. Hey. Okay, yeah. There. And qualities are here. Great. Okay. And now elevated overweight shedding, I've just been running even as we speak. And I'm guessing it's close to getting done. Indeed, it is within a few years. Oh, I haven't even been running at full speed. Okay. Okay. So, having done this, ladies and gentlemen, we can compare readily a baseline with these alternative values. And I'd like to do some plots here. But soon enough, we will proceed to do calculations within AnyLogic itself. Okay, so for the costs, these are discounted costs. That's not what I want. Right now, I'm just comparing the accumulated undiscounted costs. So here we go. Here we go. 12,000, and then the qualities here. Okay, great. Okay, now I would like you, ladies and gentlemen, to run your combined intervention, right? You have that combined intervention, remember that one? There's two combined interventions. I'd like you to first run the one that focuses purely on overweight. So it's called combined overweight intervention. Okay? Now, how do you think this one will compare in terms of the gain, in terms of the gain from the intervention? How do you think this one will compare to each of the pieces? Anyone? Should have less cost and more quality because you've got with both together. Do you think it will be additive? So to simply reflect the sum of the other two interventions? Why not? Why do you think it might not be additive? Well, because those things don't add up, right? We're getting people, so if we were getting people to lose weight more without a program to discourage gaining weight, there'd be a lot more people to lose weight, to benefit from that. Now we're discouraging both. So it may be that, there's a way in which the two combine that's less than the sum of the parts. On the other hand, they're really keeping down the number of overweight people by a combined effort, and maybe that jointly will mean a lot fewer people getting obese, which could really lower costs and potentially enhance the qualities as well. So soon we'll see, folks. This is running out. We're most of the way done. Okay? Yes, Dawn.
So I noticed a couple of people now, and I'm having trouble making sense of this. Perhaps I just missed a component. When some people have the obesity and reduced overweight, their qualities are actually increasing over time. Okay, so we have multiple people with that problem. Any idea why that might be?
intervention is doing?
Seems to be dropping the calls. Yeah.
Okay, so
Maybe we should go, I'm not entirely sure.
I definitely have increased qualities for the interventions compared to the baseline. So I suspect it may be some divergence of the models in terms of maybe a bug. I would take a look at the cost and quality mechanisms in the model to see if they're working properly for those states of obesity and overweight.
Already did. And so we go to the experiments and just make sure everybody's got the same parameters.
Sure, we'll do that. But first I'm going to just copy these values down and start another one. Okay, so we went through them step by step before, but I will go through them again here. Okay, so ladies and gentlemen, this is the combined overweight, and then we have finally, and I'll get this going and then we'll go through the assumptions, we have combined overweight and obese intervention. Okay, here we go, combined overweight and obese intervention. And this one I'm going to run, and I'd ask you to run. And meanwhile, I'm going to go through each of these interventions and go over the costs and qualities. Okay? Great. Sorry, the coefficients is what I meant to say. Sorry. Okay. So for baseline, they're all 1. For reduced overweight incidence, there's only one difference from baseline, to wit, becoming overweight intervention coefficient is 0.8. So this is reducing overweight incidence. If that were greater than 1, it would mean people would be getting overweight at a higher rate. They'll be worsening their situation. So this was 0.8. In other words, we multiply the hazard of becoming overweight by 0.8. Are people okay with that? Okay, may I go on to the next? Losing overweight, by contrast, compared to the baseline, we only change one parameter, to wit, losing overweight intervention coefficient, and that is 1.2. Next, we are going to look at reducing obesity intervention. Here we have only one difference from baseline, namely, becoming obese intervention coefficient is 0.8. I now will look at the combined overweight intervention. This one exhibits two differences from baseline. To wit, becoming overweight intervention coefficient is 0.8. Losing overweight intervention coefficient is 1.2. In other words, we lower the rate of becoming overweight, we elevate the rate of losing obesity. Finally, the combined overweight and obese, the omnibus, the full court press, the comprehensive intervention, combined overweight and obese, there are three differences from baseline. To wit, becoming overweight intervention coefficient is 0.8. In other words, we lower the hazard rate of becoming overweight. Losing overweight intervention coefficient is 1.2. In other words, we elevate the hazard rate by 0.2. Finally, becoming overweight intervention coefficient, becoming obese intervention coefficient is 0.8. And that, ladies and gentlemen, completes the cataloging. Who would like any of those repeated? Who would like those repeated? So I'm just totaling up the final scenario in my calculation. what I have. This is the picture that's emerged for me. So in terms of costs, here we have a situation where we have quite varying costs associated with each of the interventions. Here we go. And I am going to put into place this. So in terms of costs, the lowest costs are associated with the combined overweight obese intervention. Mind you, these are only costs borne with the health. We can put in some costs associated with the intervention itself, but that will require a little bit more mechanism. It's very easy to do. Combined overweight is the next lowest level of cost, and then it looks like reducing overweight, and then elevated overweight loss, and then reducing obesity incidence, and then highest costs are the baseline. So in terms of which are most successful in lowering the costs, the combined interventions do so rather favorably. And in terms of the degree of reduction, ladies and gentlemen, let us consider, here's the combined overweight. How does that compare with what we'd expect? In terms of, let's compare the difference from the baseline between this. This is a difference of baseline minus combined overweight. I have a difference of almost $3 million from the baseline. So this is difference from baseline. I would note, ladies and gentlemen, and I'll do this here, and I'll share this sheet with you so you can enjoy it. I'm going to do that for each of the others as well. Of course, there's no difference. Oops. There we are. Now, how does this compare with the sum of the savings from the other two? Well, reducing overweight incidence and elevating overweight shedding. Those two jointly together combine to somewhat more than this one here. They sum to somewhat more than 3 million. So they don't quite, in other words, the gain that you get is somewhat less than the sum of these two. In other words, you get a lot of benefit, but it's less than the sum of the benefits from the components. Let's go look at how that combines for the combined one. Well, if we total up these three, we're going to be getting something. Okay, now that's interesting. Ladies and gentlemen, if we combine naive sum of components savings, right? If we sum these things up, let's add up this plus this plus this. These are the three components. We've got reduced obesity. We've got reduced hazard of becoming overweight. We've got elevated loss of weight. Those total up to something where we would expect savings that's less than in fact we get. We get savings that are significantly more than this, by roughly on the order of $600,000. So we get a combined effect from combined overweight and obese that's well above what we get from the sum of the parts. Interestingly, that effect is not there if we consider combined overweight alone. So Jeff, is there help needed over there?
It's just a calculation.
Okay. Dylan, do you want to check it out?
I was looking before and I couldn't find it in the slide.
I see. Okay. Ladies and gentlemen, shall we look at qualities? Shall we look at qualities in a similar lens? Okay? So this is cost difference from baseline. And now I'm going to look at the cost at the QALYs difference. QALYs gained from baseline. Probably that should have been called cost savings from baseline. I stand before you neglectful. Now I'm going to compute QALYs gained from the baseline. Are you ready? Watch this. Okay? Oh, come on. You won't let me do that nice, the dream centuries. Okay. What am I doing? I stand in this. Okay. There. And I'm going to do this minus, so it's called gained from baseline. So it's this guy minus this guy, 0, and now there we go. Here are the QALYs gained. Well, that's not obvious. That's not obvious. I'm really a little bit puzzled by those results. The combined here, in this case, it actually yields more than either of its components. And it's actually, it yields an increase of QALYs that's more than the sum of its components. But by contrast, this one combined overweight and obese yields a gain in QALYs that's less than the components, which I don't fully grok. And I need to think about why that is. Sorry? That's right. This is the single highest reduction of obesity incidence by itself has that highest gain. And now, in this case, we'd expect to see something here where it's combined with something else that it would be even higher, right? So I'm going to have to look into that. That's a very interesting thing. Now, ladies and gentlemen, I would note the following, and this has to do with Joanne's point here. How much does this vary from run to run? How much of this is variable, right? After all, there are stochastics in this model. So I would suggest that we now turn our attention to working towards that ICID crown. Okay? I know you may think in Canada we know about ICID crowns. Well, okay. So, ladies and gentlemen, first thing I'd like to do is a manual exercise. It has to do right now with the question from, is it Sandra? Sandra? Sandra, yeah. So Sandra's comment that, there's a puzzle here because this one had the single biggest gain, reducing obesity. Single biggest gain in QALYs. What is it that's going on in terms of, why the combined had less? Let's go check this out. So, I am going to go down to that same intervention again, reducing obesity incidence. And now, ladies and gentlemen, mark my words. I'm going to go down to the area of randomness. And I'm going to set this from a fixed seed to a random seed. What that means is each time I run it, I will see a different result. Are we okay with that? So why do we see a different result? Because the vagaries of stochastics. Some people start in a diabetic state one and not in the other. Some people, there's some variability in when someone develops obesity or overweight. Remember, those are stochastic transitions. So I am going to set this to be a random seed in this. And what that means is each time we run it, it's going to be different. And I'm going to run it. You ready? Okay, I'm going to run it and I'm going to see how consistent they are. Is it really a fluke? And this is going to take us in a beautiful segue to the next topic and to crowning glory that we will bring. Okay? Okay, so ladies and gentlemen, I'm running this again with everything the same except different random seeds. I mean, in other words, everything the same except the luck of the dice when it comes to when things happen. So it runs out. Qualities accumulate, as do costs. And once again, we get a profile built up. We'll run this out to time 50, and I will actually go in my spreadsheet, create a separate run here. So what I will do is, I'm trying to think of the best way to present this. I can create an extra column for each of these. That's not a bad thing to do. Sure, I'll create an extra column. There we go. And this will be costs in what will be called realization. Okay. This is responding a wee bit slowly. Realization 1 and realization 2. There you go. And let's see what it brings in. Let's see what numbers we get now as we're rerunning it. How consistent is it? The good is, folks, if there is inconsistency, we have an easy way of dealing with it. And that way is called a parameter variation experiment. Okay? Okay, so, ladies and gentlemen, I need to save this so that I can upload it to you. And forgive me as I navigate here. Browse. Dylan, any luck with that? In what sort of truculence is it engaged?
I don't know, it's kind of showing results that seem very independent of the parameters you give it, and in some cases giving backward results, but everything looks right. So I don't actually know what's going on.
Is it my model?
From this morning, very nice. Different, and it's happening to the
Exactly right.
Okay, I'm wondering, Dylan, if I were you, I would look at the qualities calculation, see if there's some bug in that. Okay, so ladies and gentlemen, I've just run this again. This may shed light on the discussion. I've just run this again. We've just looked at this case of reducing obesity, and the costs here, these are costs from one to the other. It's a difference of about $300,000, just due to chance. And now going to qualities, what we see here is $96,000 here. There's a significant variability here. See that? Do you see that? What's that? 4,000, it's 4% difference? Well, but compare this with the difference from the baseline. I mean, the baseline's only at 95,000, and here, that difference is only about 5,000, and this accounts for 4,000 of it. There's variability there. So I'd say that's in terms of relative magnitudes of variability, this suggests quite an error bar around these numbers. Let's elucidate what that error bar is, okay? So let's go do that. And this is going to set us on our way for the crown.
Are you going to take us to the cloud?
What's that?
I want the cloud. I want the cost effectiveness cloud.
The cost effectiveness cloud is coming your way.
Very good.
Okay, Annie was at the announcement. She was at the announcement, where was it, Philadelphia? Yeah. Okay, so ladies and gentlemen, the announcement of the cloud-based AnyLogic running system, which will allow you to run things off the machines out there and get back the results in the comfort of your office. Okay, ladies and gentlemen, let's go now and let's add something that will save us from this variability. We've been looking at results here, but we're beset with an uncomfortable question. We are beset with the question, is what we're looking at structural differences in results, or is it the results of variability, statistically, right? There's an easy way of dealing with this. Shall we put that into place? Okay. So what we need to do, ladies and gentlemen, is we need to go add a new type of experiment. So Dylan, I think it just may have been statistical variability. I just demonstrated quite some high levels of statistical variability in the results. Even the baseline has some significant differences, I suspect, in terms of its results. So in short, ladies and gentlemen, I wish I had a flip chart here. In short, I would take each of these results as having, for a given scenario, changing no parameters, there's some sort of distribution around those numbers. And we're sampling from this distribution, but by appearances, these distributions probably overlap. In other words, this one here is some distribution around it. Maybe sometimes it's 97,000, sometimes it's 93. This has some distributions around it. And we're just sampling one value from each year, one realization. And, well, okay, for exploratory stuff, we're trying to resolve something here that requires more than one sample. Okay? So, what I'd like to do is to do the following. Yes?
If you use a fixed seed, would it give you the exact same number?
Yes, it would. It will run the exact same number. However, it will give back the exact same number, but that number isn't privileged in the sense that that's still just one pick from a distribution. It will be completely reproducible, which has a high degree of virtue associated with it. But the fact is that we really want to be able to compare with confidence resulting in a baseline and sort of say, okay, how does the baseline compare with the effect of a combined full court press intervention? In order to do that with confidence, we need to go beyond one sample of each. We need to be able to see if these are really flukes in differences, even if we ran these all with fixed seed, which I did in fact. I ran these all with fixed seed. If I had rerun, I would have gotten the same. But that wouldn't have meant that this, this difference in qualities from this to this was reliable. It's just one sample from a distribution. One sample associated with totally reproducible, but it's still just one sample.
But if you use a fixed seed, you shouldn't get counterintuitive results, should you?
Oh, you could. Sure. There's by the vagaries of the situation, it may be that sometimes if we run this with it. Well, okay, so I'm guessing there may be an important point to make, so forgive me, maybe this is not what you're thinking. If I run the baseline with a fixed seed, and then I run, let's say, this one with a fixed seed, the combined intervention, right? It's not like they are both, because vagaries in both runs. The vagaries in the baseline run and the vagaries in the other run, as to when people get diabetes, when people develop overweight, when people develop obesity, etc. And those will shape the outputs, the particular numbers that result. And you may get a situation where, for the combined case, it was very unlucky in the sense that a bunch of people early on developed diabetes and therefore imposed significant costs or developed overweight. Whereas this one was a comparatively lucky run in terms of the baseline. And as a result, the differences between statistics, either in terms of costs or qualities, are less than you would expect to see. Might even see perverse things, like where this one has a number of qualities gained, which are in fact greater than this one here, just because we're dealing with a sample size here of 1,000, population of 1,000. Now, as I may have mentioned to some people here, we typically run with small models for exploration, but when you publish a paper, you want a much larger population size. And so, for our work, very common to do at least 50,000. A presentation we just gave last week for pertussis modeling at 750,000 population. that was not for everyday exploration, it was when you needed that extra resolution. If we were running this, outside of this workshop, if this were you in your office, what I would say is, run it with a population size of at least 10,000, get a lunch, come back, and look at the results. Don't try to force it all into an hour or something like that. So we're partly, this is the variability we're seeing is partly a casualty of the lower population sizes we're using, 1,000, because I don't want to keep you all waiting, half an hour for results of every scenario. We would see more reliable results, but we're not because we're running with a small enough scenario. Let me show you, though, a way that we can deal with that in a principled fashion. Can I show this? And this is called a sensitivity analysis. But it uses a parameter variation experiment. So I'm going to go up here. I'm going to do new experiment, and it's going to be called baseline multiple realizations. We're going to run this many times. Now, frankly, a quicker solution in this case might be run it over lunch with 10,000 population. But I'm going to show you how you can do this because this issue does come up. There are models which exhibit very different outcomes, like the infection dies out versus it stays in the population, and you want to run the model many times to make sure what you're seeing is not really a fluke of that particular small set of runs. So this runs it automatically. And this, ladies and gentlemen, this exact mechanism will be the one that delivers to us the ICID diamond. Okay? And a timeout line from here. Okay. Parameter variation is what we want. Parameter variation experiment. I'm sorry? Oh, you can go name it. The key to renaming it will be to select it and then go up to the name and just type in the name.
I think she means you just created a different experiment. You can't change that one.
Oh, yeah, no, that one is rigid. Okay? Okay, so this is the baseline. Ladies and gentlemen, so I'd like you to watch my features here of what I'm doing. Are you ready? Are you ready? Okay. So I'd like you to do a free form experiment, and this is going to run, we're just going to have it run twice, free form twice. I mean, I would have it run many more times, but we don't have time. We don't have the luxury for right now. So I just want to show the principle by which it's done. Often I'd run it 100 times. I run it overnight. The computer will work while I sleep. Okay? So you can make this 100, you can make it 1. Okay, now, that's great. Okay, so we can tell it to run it 100 times. But what do we have to do after each run? Our goal is not just to have it run, and again. We need to get values out of it, right? We need to accumulate those values, do we not? Okay, can I show you how to do that? What's that? Okay, exactly. Don't worry, it's going to be doing these calculations internally in a little bit. What's that? Question? Okay. Okay, so ladies and gentlemen, let us now proceed in the direction that was requested. Okay, so what I'd like to do is I'd like to open up the experiment. Note that we have departed radically from our past experiences with scenarios. Previously, when we've been running scenarios, we run that scenario and it runs them all once. It runs main ones. Now, an experiment is going to run them all more than once. And this will be the key for statistical reliability. We're going to run maybe hundreds of times and summarize the results across those, give intervals associated with an empirical fractal or quantile interval to indicate the variability, mean, standard deviation between we will run model twice. Once for the baseline and once for alternative scenario. And it, not offhand by pen and paper, not use of Excel, it will compute the incremental cost effectiveness ratio. Right? And then, upon your head, will rest the crown. Okay. Okay. So, ladies and gentlemen, we actually need to put in place something for this experiment. And by putting it in place, we're going to be able to copy it. Okay? So, let us go open up this experiment. And now, let us go to the palette that recommends itself. And let us go to the data analysis area of the palette. Okay? And we will add into this data analysis component of the palette, we're going to add in a data set, okay, here. Now, I could actually add in a statistics data set, which would actually compute some statistics on it, but I'm just going to do a plain Jane data set. And it's going to be called costs from realizations data set. I know I could call it accumulated costs, and that would be my druthers, but I'm trying to give a nod to the local preferences. And then qualities from realizations. Oh, it should say instead of data, it should say data set at the end. Data set. Okay? Data set. Now, for each of these, you'll notice that we see something different. AnyLogic as a package enjoys a measure of smarts to recommend it. And you'll notice here that it's got this check here. We've completed iterations as horizontal axis value. So we're going to add in values, and it's going to label them with its current realization. You see what I mean? Instead of labeling with time, this is going to run this thing, and each time a realization completes, each time a run completes, it's going to add it into this data set. Add in, add in, add in. Whether it's 2 times, whether it's 100 times, it's going to keep on adding it in here. And then we're going to be able to analyze this. We can export, we have a tool which was created by an exceptional student, Winchell Chen, and he has the ability to automatically export these things to R from within AnyLogic ones. You finish running it or export it to R. And you could place these in R if you'd like to, or as it turns out, we're going to begin analyzing them for incremental cost effectiveness ratio. Okay? Are you ready? Okay. We just have to put in place the mechanism to add to these. Fortunately, ladies and gentlemen, that's going to be easy to do. So, here we are. We just have to go back to the projects and go again select this so we can see its properties in the properties window. And here, ladies and gentlemen, I would like you to scroll down. So what did I do? I went back to projects, I clicked here, and I went over to properties, and I scrolled down. And here are things that you have never seen before. There's a thing called Java Actions. Okay? Okay. And that involves not filling your cup up in the morning, but rather actions that are undertaken as the simulation runs. So, I'd like to draw your attention to this one that says after simulation run. And you'll notice that there's a little light bulb which indicates things. This light bulb indicates that some information, and in general those light bulbs are things to which you wish to pay attention. This one indicates that we can call the main class. After the simulation first, we can ask main by the name root. I know that sounds strange, but we can call it root, and we know it refers to main. So what I'm going to do here, I know it sounds strange. Okay, so what I'm going to do is I'm going to add in costs from realizations data set dot add add, and I'm going to add a number from Maine. What number would it be from Maine? What? It's the accumulated costs stock. Remember that? Remember that lives in Maine? Right? Here we'll go to Maine. We'll go down Maine. You don't have to go down Maine. I'll go down Maine for you. And here's the accumulated costs. Remember that? That's what we'll get out of there, and that's what we'll save away. That's what we'll squirrel away. Before Maine disappears, we need to squirrel this away. Okay? We need to save this away in our data set in the experiment. Because Maine's going to go away, and then a new Maine's going to come. And it could go on hundreds of times. Run Maine, salvage the value out, save it away, get rid of Maine, new Maine, run it, get the value out, save it away, get rid of Maine. So what we want to add here is nothing less than root dot accumulated costs. Oh boy, you bet you didn't think you'd do that. Okay, next thing, qualities from realizations dot data set. And we're going to add in root dot qualities. Ladies and gentlemen, this is probably almost exactly what you do with the crowning jewel. Crowning jewel. You're going to just run copies. One for based on one alternative. But here we're running the same scenario multiple times. We're not going to be running baseline alternative yet. We're going to do that soon enough. But basically the same deal. Same deal. So much the same that all your work you're putting in now will be able to copy. Ready? Are you ready for this? That's all we need. That's all we need. If you want, we could add a histogram to plot them out. But do you want to have a histogram? Or okay, you don't really care about it. Okay, what do you think? Who wants a histogram? Okay, no histogram. Let's just run it.
Sorry.
No, I do not have a histogram. Because the histogram time is short. Okay, so ladies and gentlemen, let's run that scenario. Let's run it. You can do a histogram. We've done a histogram before. We don't have to do it again. Ready? I just ran it. Now watch this. This looks different from the experiments we've seen before. There's always that button to run it. This time we'll run it like this. Ready? Now, I'll tell you a secret. It's a secret of some delight. Do you see how fast these things are going? Do you see that? Do you see them powering along? Models run a lot faster in this mode because it doesn't have to worry about presenting them visually. It's running them without the visual presentation. So this is a way that automatically you can easily speed your model up. If you don't care about the visualization for certain needs, if you're not engaged in exploratory work, you can just run it in this parameter evaluation mode. Just run it one time, and it will run faster. Okay, we're almost done with 2 rows, not 1. Why do you think I have 2 bars here? It's actually because my computer has 2 what are called cores. You ever hear of computers who say quad core, dual core? Those are my different cores. Actually, I only let it use 2 for the, you can tell any logic to not use multiple cores or whatever. So it can run it in parallel. Okay, watch this. It's just not done. 2 runs. Okay? And now we will see the results. Now will these results be seen? Are you ready here? Here we go. Ready? Let's take a look. Here are our costs. Okay. We forgot. We did something silly. Of me being me. I have didactic deficiencies. Do you notice the costs are... Okay, sorry folks. Okay, so ladies and gentlemen, can I point you? Guess what I didn't do? I didn't fix C. I need to do random seed with that. Sorry. Mea culpa. Random seed. Under randomness, for that, are we ready to rerun it? Okay, let's rerun it. It's not near as long, not really as painful as when you run it interactively. Okay, so here we go. And watch it initially leap forward. It's a smaller population initially. And then as the population size grows, it gets a bit slower. So it's running it in the background here. It's running two of them at once. Two of them at once. Okay? You notice one is running a bit ahead of the other. Due to the dangers of the situation. Yeah, I'll tell you. So it was a great question. Folks, there was a question on, is there some place you set the number of runs to run here? And there is. So this is where you set the number of runs. So I select the experiment. Thank you, sir. I set the experiment here, and further up there's this thing, number of runs, and it's in free-form mode that you can set the number of runs. The number of runs is implicit if you use varied and range. It's implied by what you've done. Okay, ladies and gentlemen. Ladies and gentlemen, here we go. It's finishing up. It's just about done with the second one. And, okay, the experiment is done. Looks like it's at 100%. Okay, ladies and gentlemen, here we go. Two samples. There are two samples of this. All right? There are two samples for the baseline, and here's qualities for the baseline. 66,000 and 67,000. Now, we could obviously copy those in. We could have done a statistics as well on them, okay? So, ladies and gentlemen, what I would suggest here is that over lunch, we run it with more runs. What do you think? Maybe run it with 20 runs, and then we could do a similar thing for the intervention, right? Do you see what I'm saying? So, ladies and gentlemen, I'd like you to change this number of runs to 20. I'm going to show you something, though, which you might like. And I do so conscious of the proximity to your lunch. Okay? Let me just show you something you might like, and you tell me if you want it or not. So this will be statistics on data set. Okay? It'll be discrete statistics, and we call it, so cost statistics, and I did get it on data set, cost statistics. I'll just show this to you. You could tell me if you want it to stay or not, okay? Do not update automatically, okay? So I just added the statistics in. I said just make it discrete, not in the sense of being careful with secrets, but in the sense of dealing with particular numbers, and do not update automatically. This is cost statistics, and then I want to copy that and make theirs being quality statistics. Quality statistics. And this will mean we'll get some results without even putting it into R or Excel. But we can do quality statistics. We'll just copy that one and pasted one. We copied the cost statistics and pasted it and just renamed it quality statistics. Are you okay with that? Okay, now watch this. Okay? Now I'd like to go back to the experiment as a whole, whence we came, and I'd like to scroll down, and after simulation run, all we're going to do is we're just going to add the same things into cost statistics and quality statistics that we added in. So cost statistics, here, another way to do it is watch this. You just make a copy and then just do cost statistics, just like that. Okay? And we're adding that value in. And similarly, ladies and gentlemen, to make your life easy, just copy this and paste and just do quality statistics, just like that. Okay? And I like to separate them as we go from one to the other.
Is it where you calculate the offer as well?
We're going to do that in this place here, but that'll be after lunch. Yeah, it's in the same place that we do it. We'll read out the values secured for each one, and then we'll compute the incremental cost effectiveness ratio. The differences in cost and differences in qualities, and we'll use some dollars for quality gain. Okay, ladies and gentlemen, I'd like you to run it. I'd like you to run it now, and, I'm sorry, sure. Okay, yeah, you bet. So I'll put it up on the big screen if you'd like. All I did, I'll tell you the secret by which I did it quickly. All I did is I copied each of the lines that was already there, and then I modified them. So I copied this one, pasted it, and I just changed this to be cost statistics. And same thing with the bottom one. I just copied this line and pasted it and changed it to be quality statistics. That's all I did. Okay, who needs a bit more time here? Bit more time, okay? Ladies and gentlemen, I have up here, thanks to Jeff's kindness, I have a little sesame biscuit, a little sesame brick that I rather enjoy. But I'm going to avoid partaking of this because I know I'm sorely hungry right now. I need to restrain my flourishing tendencies to go on. And I will not eat until food has reached your mouths. Okay? Okay. I pledge that. I will not abuse my position of power here. Okay, so ladies and gentlemen, are we ready? Are we ready to run it? Okay. If you want to see it working before you do the full kahuna, I'm just going to change it back to 2 for a minute, and I'll show it run and show you how the statistics work. But otherwise, you can set it running and you can partake at your leisure. So right now, I've started it. It is running down here in a matter of dozens of seconds, or perhaps a minute or so, it will finish. So it's taking care of running these realizations, and if there are 20 of them, it'll run 2 at a time, or 4 at a time. Does anyone see 4 bars? Yeah, that's for your computer. You have 4 cores, and they're working on it simultaneously. And so it's not quite the cost effectiveness cloud, but it at least is running many at the same time, as we need, right? We're dealing with particularly agent-based models. In contrast with system dynamics models traditionally, the idea with system dynamics models, traditionally it's deterministic. We don't have to worry about running it many times. That is an upside-downside. Here we have access to the vagaries of the statistics. We can see if the empirical data has the same degree of variability we see in the model. That's an asset. But at the same time, it does mean we have to run the model many times. Okay, here we go. Look at this. Ladies and gentlemen, look at that. It's computing the mean for us. It's computing statistics for us on cost, on qualities, the standard deviation here. Okay? Are we in good shape? Okay. So I've asked the favor of a request. I would ask the favor of a request. So ladies and gentlemen, I would like you to change this to be 20 runs, and I would like you to create a copy of this for the case of losing overweight. Actually, let's do it for the one that seemed really puzzling, right? This reducing obesity incidence. This one seemed really really sort of anomalous in terms of the gain here, and out of whack with what we saw later. So reducing obesity incidence, I'm going to make a copy of this parameter variation experiment, and I'm going to paste it in, and I'm going to make this not baseline multiple realizations, but reducing obesity incidence multiple realizations. Reducing obesity incidence multiple realizations. And what do I have to change in the parameters? Does anyone remember? For reducing obesity incidence, what do I have to change? I made a copy. No, I didn't create a new experiment. I copied the multiple realization experiment we already have with all those statistics and so on. Yeah.
So sorry, you copied the realization,
There's multiple realizations.
the original simulation.
Correct. I did this new one we just spent time creating. I just copied this one, the multiple realizations. Oops, no, I don't want to cut it. Copy it. I want to copy it, and then I went up to the model as a whole, and I pasted it. And having done that, now I have this one which I can apply to my will. I can bend to my will in terms of customizing it for reducing obesity incidence. What here has to change to make this run? Yeah, this becoming overweight coefficient needs to turn to what? 0.8. Becoming obese, and this is the reducing obesity incidence, yeah. Okay? Yeah, I just changed this parameter here. This one here. So in short, I right-clicked on this, I selected copy, I went up to the whole model and I did paste, and having pasted it, it looked kind of like this, and all I did is I changed the last one to be 0.8. I changed the one that becoming obese, I should say, becoming obese. Okay? And now I'm going to get those running, and let us now partake of food. So I'm going to first run the baseline, and then I'm going to run the others. Secretly, while you folks are eating, I'm going to run others yet. Okay? Here we go. Let us eat while it computes. Happy to do so. For this alternative one, reducing obesity incidence, the only difference is this one is 0.8. That's the only difference.
A lot of people, when they have 100 as their population size, will just instantly finish.
Yes.
Yours is taking a while. So for them to see it take a while, they'll have a population of 1,000.
Oh, that's what it was supposed to be.
Yeah, so yours is 100.
Oh, it's 100? Okay, that should have been 1,000. I stand remiss. Thank you, Bill. That should have been 1,000. That should have been 1,000. I'm not sure how that crept in there. Thank you. Thank you very much. Both of these should have 1,000 in there. No wonder it was going so fast. Okay. Okay, run it to the baseline. That's also going to make a difference in terms of costs and qualities for sure. There we are. Okay. So I'm now running it with 1,000, and those will take a more steep amount of time. Some of them pretty fast at first. A lot faster than before. Okay. Are we all set? Okay. You can set yours running. Make sure it's 1,000 for each, and set yours running. 1,000 for each of those new ones, parameter variation, and set it running, and we will observe the results. And ladies and gentlemen, after lunch, we will set it running and perform incremental cost effectiveness calculations over multiple realizations. Okay? Okay, thanks. Lunch is served, and I will not eat until you've had a chance to.
Thanks, I've enjoyed this. I just want to say I'm really leaving. So
okay.
I'm really interested in except for these part. The other thing is, so my numbers in the baseline were in like possibly in the range of 6 million, I think.
Okay.
When I've done this, I don't know too much to cost. Like, and, you know, so...
I think it was published as 100.
1,000 though.
Yeah,
Yeah. So I'm just unclear why I'm getting such big differences. It doesn't make any sense.
you know, it's,
And the quality's the same thing.
I have an idea. Can I check something? This is something I didn't check, and I stand remiss. We were doing stop time 50, what would we be doing for these ones? Is it the same? Stop time 50? So you wanted to make sure that they're the same stop
Line is
time?
the same.
Yeah.
Okay, I'll double check.
Because if the starting is different, they'll be called to an earlier point, right? Like, or to a later point, and so it's not really apples to apples.
Okay, I'll take a look at the stop time.
Yeah, see if it's the same. If not, maybe get Dylan to take a look at them all.
Yeah.
And, because I would expect comparable results.
Be cut in the ballpark.
Exactly.
Yeah. It's
Yeah.
off by a couple of million.
Yeah. So I may not have advertised that well, that it's, I mean, mine here is starting up here, right? And so like right now, it's 14 million, and my earlier results were, they're in that ballpark.
Yeah. Well, that's what I was expecting. They'd be
Yeah.
close, but yeah.
That's what I expect. And this is 97 million, or 97,000 rather, and again, it's in the right ballpark
See,
for
mine
this.
are off, yeah.
Yeah.
I'm at 5 million and the police are around 33,000.
Yeah, but when you do this, I haven't run that.
Haven't run that.
Yeah, well, that's what I'm saying, is so when I run the, what do you call this again?
The parameter variations.
Parameter variation, so looking at variability, those numbers are off from what my baseline numbers are.
Okay, yeah.
And that's what I'm kind of going, doesn't, shouldn't be.
Yeah. Yeah, thanks for mentioning that, and if you get the Dylan to look at it.
So why are we doing a compare runs experiment?
Because compare runs is not as general, and it's, I frankly never used it significantly, and I think it's, I mean, especially, we're going to want to be able to do this for incremental cost effectiveness ratio, and compare runs, I'm not sure is as convenient for doing that. Okay. I mean, if you think it's more convenient, I'd be interested in looking at it. I've looked at it before, and it just didn't